All right. So what we've done so far, we've written down our ions. We found those where?
On the ion sheet.
On the ion sheet, because ammonium and thiosulfate are not elements. We have to look on our ion sheet when we get anything that sounds weird, right? Okay. So we're going to get rid of our plus. We're going to get rid of our minus. We're going to move the imaginary 1 over there. We don't write it when we write a compound. We don't write a 1. We're going to take the 2. We're going to move it over here. But I can't put the 2 right by the 4. I can't put 2 subscripts next to each other. So I have to put it in parentheses. Good job. So I have NH4 parentheses 2 S2O3. Are we okay there? Okay, what's the question, Rachel?
Is that 2 over there still in charge?
Where?
On that side.
That 2 is a subscript. That 2? That 2 tells you how many NH4s you have. It is not a charge when it comes down to the bottom. It's a subscript.
Okay, but that's for the whole thing.
Yeah, it goes to the NH4. It tells you how many you have. Okay, what do you got there?
So when you want to, so since it's saying you have 2 NH4, you just multiply that number by.
All right. What do you got, Scott?
No, I just said it's like you distribute it.
It's like you distribute, exactly. So when I find the formula mass, I'm going to say N is my imaginary 1 times 2, so it's 2. Times 14.01 is 28.02. Then I have 8, which is how many? 8. 4 times 2. Which is 8.08.
Yeah.
Then I have X, which is 2 times 32.07, which is 64.14. Then I have O, which is 3 times 16, which is 48. Then I have to add all that up. Right?
Yes, I did.
You added, or no, you added right. I added wrong. I was adding in my head and carried it wrong. I don't know.
Because you multiplied 4 times 2.
Really? All right, so I have 148.24 grams per mole. Now if I want the percent sulfur, I take the total mass of sulfur, which is what number on the sulfur line?
64.
The 64. It's this. So it's 64.14 divided by 148.24, and then I multiply that by 100, and I get 43.27%. All right, and that's the percent sulfur. All right, what you got?
Do we always learn to do that question?
Yes. You cannot use the number right here, which is the mass of one of an element. You have to use the number on this side of the equal sign. Okay? What you got?
For 8, how'd you get 8?
4 times 2.
Oh.
You gotta distribute. All right. We okay here? Yeah. All right. Okay. So we're back, and all right. So a molecular formula is something like, well, any formula, any compound. You can call it a molecular formula. It's just how it's written. Like CaCl2, calcium chloride. C6H6, benzene. All right? Just how you expect it to show up. All right? Just how it exists.
So, can it exist like in any other way?
A molecular formula is just a compound. Molecular formula just means a compound, how a compound exists. Okay? So, what you got?
So can it be a molecular formula without any substance?
It could be. So like NO or, yeah, could be. You know, it could be a covalent compound or like NaCl. Yeah, it can be. So just how it exists with its expected subscripts, whether the subscripts are imaginary ones or it has them. Okay? An empirical formula. Do I need to go back? No? It's the formula for a compound in the reduced simplified format. All right? Meaning it's got the lowest whole number ratio that it can. So, for example, C6H6. How can I reduce that? The lowest thing I can reduce it to is divide both of those subscripts by 6, right? They're both 6s, right? So, one option is to do C6H6. If I divide, I divide by 6, I get CH. That was interesting. All right. What about this one? What about H2SO4?
HH2.
Okay, what's the common thing between the subscripts? I have a 2, a 1, and the 4. It's the 1, right? All I can divide by is 1. So nothing changes. So,
If you're trying to reduce it, why wouldn't you just divide by 2 and get HSO2?
because I can't have half an S.
Oh.
All right? Good question. I can't have half an S. I can't have a fraction as a subscript. All right? So one option to find empirical formula is called dividing by the greatest common factor. All right? So we divided by the greatest common factor of the subscript.
God bless you.
Whereas one like this, what if we have N2O4? What would we divide by?
2.
We divide by 2, right? And we would get NO2.
Does that say GCF?
Uh-huh. Greatest common factor. All right, so that's one way to find the empirical formula. There's another. All right, that one seem okay?
Is it easier or harder than that?
It's a little bit harder, but it's not horrible. All right.
So that's N2O4.
N2O4. Mm-hmm. All right. We good here? Yes. Yeah? This way makes sense.
Yeah.
Yeah, seems kind of easy, right? Okay. Here's the next way that you do it. You're going to be given percentages. You'll be given a percent. You're going to call it grams. You're going to divide by the mass from the periodic table. All right? You're going to get some ratios. Divide by smallest ratio. If they're whole, stop. If not, If they're a whole number, you stop. If they're not, you go from there.
Like, instead of giving us a 10, we'll call it grams and there's a 5.
By the mass of that number on the period. By the mass of, right. I'll show you what I mean.
And then, what about the ratio?
Okay. I'm going to show you.
Do you get off the number and with like some decimals, like saying 14.01?
So it's called 14. Yeah, I'll show you. So these are the steps, but let me show you what we mean. We'll do a couple of these.
Is this like better? It's like, is it like more, like a more efficient way to get simplified or no?
It's a different way to do it. It's based on the data you're given. Okay? All right. Here we go. You'll be given a problem that looks like this. So you have, I'm not making this up. Got a book in my hand. Okay? So in a problem, you're going to be given a set of percentages for an element or a series of elements. Okay? So you have 10.4% carbon. 27.8% sulfur, and 61.7% chlorine. Now I'm going to think of each of these percentages like grams.
Wait, is that like are those the percentages of the compound?
Yes, it's the percent that the compounds are made of. The percent composition. Okay? I'm going to think of them like grams. Now what I'm going to do is I'm going to find my calculator. I'm going to take this number, I'm going to divide it by the mass of carbon on the periodic table. What's the mass of carbon?
12.01.
So 10.4 divided by 12.01. When I do that, I get 0.8659. Okay? Now I'm going to do sulfur. 27.8 divided by 32.07. .8669. Yes, ma'am.
Was there ever been a time where the percentage is bigger than the mass?
That's the next one. 61.7 divided by 35.5. I get 1.738. Okay. So now I'm at the ratio part. Which of these three numbers is the smallest?
The first one.
The first one, right? So I'm going to divide all three of these by that
To get the ratio.
to get a new ratio. Okay? So I got my first ratio. Now I'm going to divide all three of these to try and get a whole number. Okay? So I'm going to divide all three of these by the smallest ratio, which is that one, to get a whole number. Or to see if I can. So divide this by 0.8659. Well, I know that's 1. Right? If I do 0.8669 divided by 0.8659, that's 1.001. Well, shoot, that's 1. Okay. 1.738 divided by.
That's 2. No, it's not. That's not 2.
0.8659
That's like
is 2.007. Since I don't have a number after the 2 till that third decimal spot, that thousandth spot, I'm going to call that 2. These whole numbers become my subscripts. So what's my formula?
CSCLC.
C S C L 2.
What's it called?
Oh, so you're gonna like round it?
Right. You're going to round. Now, if I get 2.5, I can't round. I'd have to multiply. What would I multiply 2.5 by to get a whole number?
10.
2. That would make it 5. And what I do to one thing in math, I have to do to the others. So if that was 2.5, this would become 5. That would become 2. And that would become 2.
So, multiply it by even.
We'll do another one. I'll show you one.
Wait, so you don't.
Okay. Hang on. Give me what you got.
Wait, so I got to the part where after you divide, yes, that part, and then,
You divide by all of them by the smallest one.
okay, got it.
Okay. All right. Either where were you?
Can you, repeat, how did you end up with the two, why, because it's, on the finance?
Okay. These numbers, the 1, and the 2, become your subscripts in the formula. So I have 1C, 1S, and 2 CLs because I ran.
Okay.
All right. Nick, where were you?
The factors, what factors? That's just the numbers.
Okay.
The things that turn into factors.
We'll get to one. Let me do one where we're not going to have a whole number right here. All right.
So why you don't round even if it's because you have 2.007.
Right.
So
That's 2.
So you just don't round at all for the sub part.
Right. So, all right. Let's do another one. All right. Let's try. Let's try this one. 55.3% potassium. 14.6% phosphorus. And 30.1% oxygen. All right. So, what do we do?
You gotta find the mass for, well, turn it into grams first.
No, we mentally turn it into grams, right? So 55.3 divided by 39.1. Someone tell me what that is.
1.41.
Keep going. Couple more decimals.
1.4143.
Okay. 14.6 divided by 30.97. Huh? Zero point
714.
0.735.
Give me one more number.
Wait. Hold on.
0.4714.
Yeah.
That's what-
0.4714.
0.4714.
Good job.
Who did that?
Loud.
0.4714. Okay.
That's 1.8813.
All right. Which one are we dividing by?
The second one.
Second one, right?
Yeah.
What do we get here?
1 The first one is 45.147.
3.99, right? So if you're at 3.99, you're going to call it 4.
Oh.
So, K3, 4.
Okay.
And then,
Yeah. No way.
alright. So, here's what would happen.
K3.
What I mean by a factor is, if you get an answer right here that's like 1.33, right? Instead of a whole number, what would you have to multiply 0.33 by to get a whole number? 3. So let's make a list, right?
4.
Alright, so if your decimal is 0.25, you multiply everything by 4, right? Because that's a quarter.
Yep.
If your decimal is 0.33, you multiply by
3.
3. If it's 0.5, you multiply everything by 2. If it's 0.2, you multiply everything by 5. That's what I mean by factor.
What's this 15?
Okay?
Because I remember seeing something like that.
If it was 0.67, that's the same thing as 0.3, right?
You just want to get to 1?
Huh?
You just want to get to 1?
You want to get to a whole number. It's not going to get to 1, but it's going to get to some whole number. Okay? All right. There's a third type of empirical formula based on the information they give you. Okay? They may ask you to find the molecular formula. So, they could give you something like this. They could say that the empirical formula is something like this. Yes, ma'am.
My bad. What's the last one again? The last factor?
0.67 should be the same thing as 3, right? Still a third. All right. So they could give you an empirical formula, but then they could tell you, they could give you an empirical formula. It has its own mass, right? But then they could tell you the molar mass. The molar mass is the mass of the actual compound, not the empirical compound. Okay? If the molar mass
so the first one is just the simplified.
is the simplified, exactly. So if this is 90 grams per mole, what's the mass of this? How do we figure that out? We know that, right? You can find the mass of anything. So what's the mass of this part? Right, so find the mass of this part. Right? So 1.01, or we could just, since they gave us a whole number, let's get rid of the decimals. So we're just going to say 1 plus 12 plus 2 times 16, right? So 13 plus 32
Plus
is 45, right? So that's the empirical formula of mass. So this is the EF mass. Okay. It's still just the mass of hydrogen, the mass of carbon, the mass of oxygen.
rounded it.
Since they didn't give me decimals, I just rounded. Okay? What's the difference? What's the ratio between this and that?
1 to 10.
1 to 2, right? It's cut in half. So if I want to double this, what's the molecular formula?
It would be H2.
H2C2O4.
You're doubling it because of the gram.
Right. Because I find the ratio between the two then, and then I double all my subscripts. Since the grams are cut in half, I know I have to double my subscripts to go up to the molecular formula. Okay? They can give it to you in reverse. They could give you the molecular formula and the empirical mass and make you go backwards.
What about
Same way.
molecular and what would you do there? Would you ever use something like that?
What?
If it was the molecular formula and the molar mass and you had to find the empirical, what would you do with that? You just
That you'd have to have more information. If they gave you the molecular formula and you want the empirical formula, you just reduced it. That's easy. They can ask you then what's the empirical mass and just calculate what the half of it is. That's easy. That's just a molar mass question. What you got, Reed?
No.
You sure?
Yeah.
You sure? Okay.
I mean, I was just gonna ask like,
What you got, one?
Okay, so, you know when you do 1 plus 12, where do you get the 2 something?
The subscript right there.
Oh, okay.
All right. You okay? Okay. Yeah. You just stretching. What you got,
how'd
Jeff?
you get the two?
The 2 came from the
because you have to
subscript right
double
there.
it to get to the molar mass.
No, I'm talking about.
Okay. 45 goes into 90 how many times?
Twice.
2.
You get the two too.
No,
So
that's
then,
just
it's the ratio.
No, isn't it just double?
And then I double it. So then I'd say do 2 times 1, 2 times 1, 2 times 2. What you got, Sam?
Can we do another one?
Which type?
A hard one. Yeah, do another one that's one like this.
Another one like this?
Yes, like the
Okay.
one that we're comparing the two.
Okay.
Hard.
All right.
Do
something really, really hard.
You're not that hard.
No, so make it hard. Make it hard.
I can't. They're-
Rachel can get the hard one.
I can only make these as hard as they are. I mean,
No, it's hard enough.
yeah, use whole number.
What would you do? Would you just round down or would you round up?
Round down what?
For CL?
No, 34, 5.45. All right.
Oh, so you just leave the same.
Okay.
Alright.
So, for n, I have 14 plus 2 times 1 plus 30, they're saying 35.5.
That's the.
Wait, that's the decimal.
Yeah.
Miss Penny, why'd you put a decimal for just that one?
Because chlorine is a decimal.
Okay.
Alright? So, I have 17 plus 35.5.
You get 50.5.
No, I don't.
51.5.
I get 51.5. So in this case, the empirical is
The molar.
So
The molar.
there's no ratio.
There's no ratio, it's 1 to 1. So the
And the
molecular,
molecular is the same as the empirical.
So what do you?
Wait, isn't that 16?
You put the decimal.
You put the decimal when it's not like close
Betty, you
to.
put 14
You put
plus
17.
Oh.
One?
It's okay, we're
I mean, a whole number?
Yeah.
brain part.
It's okay.
Like if it's 1.01, like
Okay.
then you just give it 1.
All right, chlorine's molecular weight is 35.45. So if you round it, you have to do 35.5. Chlorine is weird. Chlorine is weird. So the molecular is the empirical in this case. It's a 1 to 1 ratio. All right. So those are the 3 ways that they can do empirical and molecular formula. It's not horrible. To where if you were to look at your choice board, all right, it says that for the 85, you have to do the worksheet that's uploaded online. It gives you, and if my memory serves me right, there are 6 problems like this on it.
Okay.
There are, oh, stop it.
Well, 1 is 2.
There are 4 like this. And then there's a couple that have you do this and then ask you, once you find this, what's the mass of it? Or something like that, that add a piece. Okay? So it combines this step with step 3.
Is that the test or the objective?
It's objective 6. That's what the worksheet's like.
Um,
Okay? And then you have a quiz on Schoology. So, here's what's coming up down the pipe. Hopefully you did your quiz that was due last night. All right? You have an ionic covalent acidic quiz due on the 29th. All right? Your molar mass quiz on Schoology, which you should be able to do, that was pretty easy, what we did yesterday, right? Is due by the 4th. You get 2 shots. There's a quiz over this. It's not due until the 8th. Okay? And it'll have 4 questions on it. You get 2 tries. There's 4 questions on the formula mass quiz. You get 2 tries. Alright? So, that's kind of where we're sitting. The last thing we have to talk about in this unit is organic. But it is. But it's one of those things, there's more reading in that packet than there actually is stuff to do. And that's one of those that I'm going to print that packet out for everybody on probably later this week so that you guys can get it in your hands and start looking through it. So, but that's one. So that's kind of where we sit. Okay, you have got 30 minutes to work.
No, that's this.